All right, so here's a quick wrap up of this page. Again, please, you have to do this before you watch me do it, okay? If you just watch me do it, you're not going to learn anything, okay? All right, so hopefully you should see your position versus time graph. Okay, should look like this, which from math you probably recognize as a concave up parabola, okay? So this should tell you that the puck is speeding up, okay? Because in like the last section, right, when the position versus time graph is linear, that means that for every 1 second over, right, like it goes like 2 meters up, 1 second, 2 meters, 1 second, 2 meters, okay? And this is going to be a position that's increasing linearly with time, right, by the same amount every time. If you look at this graph, every time I go over 1 second, I go up just like, like a meter. Another second, I'm going up more. Another second, more. Another second, wow, more. Okay, so this is a position that is increasing increasingly, which is kind of a weird way to say it. Okay, so I like to say position is increasing increasingly, right, instead of evenly with time. Okay. Is the slope of the position time graph steeper towards the beginning or towards the end? So hopefully what I'm hoping in Class Kick is if you go back to the last slide and you have your screenshot of your graph in there, that you can actually use the drawing tool and draw over top of it, okay, which I think you can, all right? So what I want you to do is if you have this graph, however yours looks, okay, I want you to go in and hopefully you've drawn tangent lines. So like maybe one here, and one here, okay? And then estimate or calculate those slopes, all right? On the old AP test, I don't know how this year's is going to be, there's a fairly good chance of getting a question where you have to draw some kind of a tangent line by hand and then take the slope of it, right? So don't pick the tangent point, okay? So try to see if you can estimate like 2 other points on those lines, all right, and then make your slope calculations, okay? But then this one should be, faster, this one should be slower, and this one should be like some medium number, okay? But understand this tangent line. This is what we're really trying to look at. This tangent line slope is increasing, okay? That's the next question. Okay, the slopes of the line, so the tangent line slopes are getting steeper. Okay, and remember the slope on a position graph is the velocity. Okay, before it was just sort of the average velocity, right? When it was a line like this, okay? But now this is a changing velocity, so we call this one the instantaneous, means at that exact moment, what is the slope? And then what is the velocity at that moment, all right? So that's what you're going to do by calculating these tangent lines. And as you can see, the tangent lines get steeper, which means that it's getting faster, right? The velocity is increasing, okay? All right, and then some of you are probably already starting to draw the parallels to calculus here. Some of you haven't got there yet, that's fine. But really, before you even understand the calculus of it, you should understand just the basic, simple nature of the fact that those tangent line slopes are getting steeper. All right, and that's it for this page.